All right, so in this video, we want to solve these exponential equations over here, and there's going to be some log equations as well, but we want to solve the log equations using the exponential method because that's what the question specifically tells us to do. Let's get into the first question over here. If I look at this first question, it's impossible for me to make these two bases the same. So I want to use my rules of logs to solve these equations. I'm going to start by doing the log of both sides. Once I do the log of both sides, I want to bring my base down using the rules of logs. So I have t minus 1 times log of 5 equals log of 3.92. And then I want to divide both sides by log 5. And over here, log 5 and log 5 just cancel. So I'm just left with t minus 1. And over here, I'm going to do this in my calculator. So log 3.92 over log 5 is 0.8488. I've rounded to 4 decimal places here, but take as many as you need. Then I'm going to just move the negative 1 and add it. So 1.8488 is my final solution. This second question here, I could just put this in my calculator, or I could even write this as log 25 divided by log 3 and then put that in my calculator. That would be the quickest way to solve this log question here, but they want to do this question in terms of exponents. So I'm just going to show you really quick. It's not very practical. You'll probably never ever see it in a test, but just in case it shows up, I'm going to show you how to do it. So we want to first convert this to exponential form, which means we have to do the base to the power of both sides. So I'm going to do 3 to the power of both sides. So on the left side here, I have 3 to the power of x, and on the right side here, 3 and log 3 cancel, and you're left with 25. Then it's pretty much the same as this question over here. I can't make these two numbers the same, so I'm going to log both sides. I know, a bit ironic because I got rid of the log and now I'm adding a log, but that's just how it's done. I'm going to bring my exponent down. And then I'm going to divide both sides by log 3. And like I said at the start of this problem, the solution is just log 25 over log 3. You can actually tell that from the original equation here. So this method, like I said, is totally unnecessary. I don't know why books or teachers would ask this, but just in case it does, like I said, I wanted to show the steps. So log 25 divided by log 3 is 2.93 if I round to 4 decimal places because it's just nines after that. I guess 3 decimal places. And let's try this last question over here. So again, I can't make the bases the same, so I'm going to log both sides. Then I'm going to bring my exponents down. And now I'm going to just divide. Again, there's a lot of ways to do this step, but I'm just going to divide both sides by log 4. Actually, probably would have been better to divide by log 5. So I'll actually divide both by log 5, because then I get rid of this log, which is a bit more complicated on this side. So now I'll do log 4 divided by log 5 in my calculator. And I get 2x times 0.861 if I round to 3 decimal places. Then I'll do 2 times 0.861. I get 1.723x. Again, I use the exact value, not the decimal value here. I will subtract this 2x on this side. Get negative 0.277x equals negative 1. Then just divide by negative 0.277 on both sides. and you get the final answer as 3.606 if you round to 3 decimal places.